So for a parameter theta, consider the following statements. Minimum of x1, x2, so on xn is a sufficient statistic of theta. X bar is the minimum variance unbiased, minimum variance bound estimator of this theta. So which of the following statements is are correct? So if we consider f of x comma theta, which is e to the power minus of x minus theta when x is greater than theta. So first one is the minimum sufficient statistic is a sufficient statistic of theta. This is correct because this is a location family with support depending only on this theta. So the joint density is non-zero exactly when theta is less than or equal to x1, x2 and so on. So basically x1, x2 and so on xn is greater than theta. So the minimum value must also be greater than theta. So that means theta is less than or equal to minimum value of this x's. So it depends on the data only through the minimum. So the by factorization, minimum statistic is a sufficient statistic. So we can also see like more concretely if we have to see like it is indicator of theta less than or equal to theta 1 e to the power n theta. This is the likelihood. So the sample minimum is sufficient because and moreover like if you consider x1 minus theta, this has a distribution independent of this theta. So this also implies that it is sufficient because it is completeness statistic, and we can also in fact like use this for UMVUE. So that's about the first statement. Now if we consider the second statement like x bar, which is 1 by n summation xi is minimum variance bound estimator of theta. So first if we find expectation of xi, so it's a shifted exponential, so that will be theta plus 1 because xi follows theta plus yi follows exponential 1. So that means so that's why like we are having expectation of xi is theta plus 1. So that means x bar minus 1 is unbiased for this theta. So that means x bar, but like if we try to say x bar minus 1 is not complete sufficient statistic, not even a function. So not a function, so let me write properly. So x bar minus 1 is not a function of complete sufficient statistic because we have seen like earlier, like in the earlier part, so x of 1 is a complete sufficient statistic, x of 1 alone. So it can't be the UMVUE by Lehmann-Scheffé theorem. So UMVUE must be a function of x of 1. So this is not correct and this is correct. So therefore only option A is the correct answer.